Okay, now we're going to continue our talking about valid argument, but this time we're going to have some quantifiers. So as a reminder, what are quantifiers? The ones we'll be using are all, some, and none. In more mathematical, logical systems, you might have there exist, meaning there's at least one thing, but okay, we'll use these three. And with some, we'll mean some are, some aren't. So that will be an implied thing, but we'll take it to be true. If we use some are, and some aren't. Okay, we also introduce an element. So we had set theory before. If we want to say that something is a member of that set, in our diagrams, we'll just put a dot on the circle. So a set inside of a set is a circle inside of a circle. But an element inside of a set is a dot inside of a set. Now, in the valid argument with the truth tables, we looked at every possibility. And by that I mean we looked at every single line in the truth table, which covered all the possibilities of true and false that could possibly happen. And we investigated each one, and we looked to see if there were any instances where the premises were true, but the conclusion was false. And if there was any such premises, we would say that the argument is invalid. And if there were no such premises, we would say the argument is valid. So what we're going to do is not do truth tables. We're going to draw diagrams. We're going to draw diagrams which show that the premises are both true. And we're going to ask ourselves, is there any possible way to draw this so that the premises are true in our diagram, but the conclusion is false? And if there is any possible way at all to show that in a diagram, then our argument is invalid. And if there's just no way you can get around that, anytime the premises are true, the conclusion must also be true. Well, then it's a valid argument. So, excuse me, I'll start with a valid argument. Okay, so for my premises, I have all firemen are buff, and Joe is a fireman. And for my conclusion, I have Joe is buff. So, to show all firemen are buff, I have to put the fireman circle inside of the buff circle, as you see in the diagram here. To say that Joe is a fireman, I put a dot, or that Joe is an element of the set of firemen. I put a dot inside of the fireman circle, and we label that dot Joe. Now, as soon as you do that, Joe is automatically an element also of the buff circle. There's no way to get around it. And so this is the only possible way that the circle can really be drawn, with the Joe dot inside of the fireman circle, which is itself inside of the buff circle. And this shows that Joe is one of the elements of the buff. So, okay, the conclusion is true. No way to get around that. If you, as long as you draw that the premises are true, the conclusion must also be true. That means it's a valid argument. Okay, let's go for some invalid ones. I changed my all to a some. Some firemen are buff, and Joe is a fireman, so Joe is buff. Okay, so we draw the some firemen are buff, so we overlap those two circles. And now we're going to put Joe somewhere. Joe has to go inside the fireman circle, but the question is he over here, or is he over there? Could be either. I mean, both premises would be true. We'd have an overlap. That shows the first premise is true. Joe is a dot inside the fireman circle, whether I put it there or there. Joe is a dot inside the fireman circle. Now, must it be true that Joe is buff? Is there any possibility to draw this so that Joe is not buff? Yeah, there's a possibility. I could put the Joe dot over here. And by putting it there, it's outside of the buff circle. So, it's possible to draw a diagram in which both of the premises are true and the conclusion is false. With that possibility, we say this is an invalid argument. Okay, another invalid argument. And this one does not involve an element. All mammals have a heart. Okay? All birds have a heart. So, all birds are mammals. Alright, well, let's see here. So I have to put the mammals circle inside the heart circle. And I have to put the bird circle also inside the heart circle. But I really have 3 possibilities. I've only shown one of the 3. Or actually 4 possibilities, come to think of it. The bird circle has to be inside of the heart circle. The bird circle could have completely encircled the mammal circle while still being inside of the heart. That's a possibility. It could be completely separate, as I've drawn here. It could be there's some overlap. It could be that the bird circle is completely inside the mammal. So I can think of 4 possibilities. In one of these, actually, in several, and 2 or 3 of these, we do not have the bird, all birds are mammals. Actually, in this one, no birds are mammals. So it's possible to draw a diagram in which both premises are true, and yet the conclusion is false. With that possibility, we'll have to say this is an invalid argument. So in conclusion, there's really some imagination here, it's some visualization skills. You have to consider all the possible diagrams that could be drawn and what the 2 premises are true. And then if any of those have a false conclusion, you draw it, you say, nope, it's invalid. On the other hand, if all of them come out to be true, all of them show a true premise, what you really should be doing is drawing all such diagrams, all possible diagrams in which the premises are true. And you say, in each and every one of those, the conclusion is true. And if that were the case, I didn't have an example of that, but if that were the case, I would say, yeah, it's a valid argument. Okay, that's it for this. It's a rather short video.